everyone, welcome back to the NBF Chemistry series. In part 3 of chapter 1 of your book, we covered the fundamentals of inorganic chemistry. Today, we are going to shift our focus to another crucial branch of chemistry, that is the physical chemistry. So, let's get started. The term physical chemistry is quite self explanatory. It focuses on studying how things behave physically, which means that it deals with the physical changes or physical properties of elements or compounds around us, such as the temperature changes, pressure changes, and concentration changes of a compound or an element. But why do we need to study physical phenomena? For example, we know that when we decrease the temperature of water, it turns into ice, and when we increase the temperature of water, it turns into steam. So, the simple answer to all of this is that all the physical changes that we observe around us, like how ice melts into water or why a balloon pops if too much air is pumped into it, all of this is stuff is explained by studying the physical chemistry of these elements or compounds. Now, what kind of information do we get after studying physical chemistry? We get rules, laws, and different theories. By studying all of these processes, we gain a better understanding of how things work and behave around us. And all of this knowledge allows us to develop fundamental principles or rules of nature, such as various laws and different kinds of theories. One such example, and a very common example that you guys might have heard of, is the law of conservation of energy, which states that energy can never be created nor destroyed. Now, how did we come to this conclusion? It's all thanks to physical chemistry that we have observed and studied energy over various periods of time, noticing that it has always changed forms from one form to another rather than being created or destroyed over time. So, to understand all of this concept more clearly, I have an example. This example is also based upon a very well known principle that states that increasing the temperature will probably increase the speed of reaction. That is a well known principle or a rule. So we'll see that in this example. The example is the dissolution of tablet in cold and hot water, and we'll see in which kind of water the tablet will dissolve more quickly. Now, you can clearly see that it took less time for the tablet to dissolve into hot water than cold water because of the increased temperature, which certainly proves that this principle is right, that increasing the temperature will always increase the speed of reaction. Now, coming towards the explanation of physical chemistry from your book, the definition states simply that it deals with laws and theories to understand the structure and changes of matter, as I've already told you. Now, the essential questions for physical chemistry is what is the structure of an atom and how does it influence the chemical behavior? And second is how do different types of chemical bonds, such as ionic, covalent, and metallic bonds, form and function? Now, whenever you encounter questions about bonding, different types of atoms, history of atomic models, remember that all of this falls under the branch of physical chemistry. Next up, we have the daily life application of physical chemistry. The most common daily life application is the batteries in vehicles, which are built upon the principle of electrochemistry. It is a very interesting topic that we will encounter later on in your book that I will explain to you. So that was all about the physical chemistry. Next part will be based upon the analytical chemistry. So stay tuned for that lecture as well.